To build a private AI workspace that you actually control, you have to move away from third-party platforms. Hosting your own interface gives you a private, always-online environment where your data remains within your own perimeter. By the end of this process, you will have a clean, chat-style dashboard living on a custom domain. It will be secured by SSL encryption and wired directly into your own local intelligence models. Many users try to run this setup on a personal laptop, but laptops go to sleep, drop their internet connections, and quickly run out of memory when processing large AI tasks, taking your entire interface offline. This chart shows the stable deployment architecture. Traffic flows from the user through an NGINX proxy into Open WebUI and down to Ollama. To build this pipeline, you need an Ubuntu VPS, a custom domain, and basic SSH access. Shifting this entire architecture from personal hardware to a dedicated remote server is the only reliable way to keep your AI data private, while ensuring you can access it from any device at any time. Before logging into the server, we need to address hardware limits. The Open WebUI dashboard itself requires very few resources to run, but the moment you ask a local AI model to process a prompt, memory usage spikes. This chart shows how RAM and CPU needs scale depending on your workload. If you only want the web interface connected to external APIs, 4 GB of RAM is enough. But if you plan to test local models, you need to step up to 8 GB, and scaling past 16 GB is necessary for larger workflows. Connect to your server via SSH. The first command you execute must be an update and upgrade of your Ubuntu packages. Starting with a fresh system prevents package conflicts later in the installation. Running daily administrative tasks as the root user leaves your server vulnerable. Create a dedicated, non-root user. We'll call it Deploy, and grant it sudo privileges to handle the rest of the configuration. Next, install Docker. We will use the modern Docker Compose plugin, which allows us to define our deployment parameters in a single, easily editable configuration file. To verify the installation, run the standard Hello World test container. If the daemon returns a success message, your container architecture is fully operational and ready to host the dashboard. Securing the correct amount of RAM upfront and confirming the Docker engine works properly now will prevent your deployment from crashing during model inference later. Create a clean, isolated directory for the project. Inside, generate a persistent cryptographic secret key. Open WebUI requires this string to maintain secure, stable user login sessions. Place that secret key inside a hidden environment file. Storing admin emails, passwords, and security keys here keeps sensitive data out of main operational logic, making your setup much safer to edit later. Now create the Docker Compose file. This defines the Open WebUI container, sets it to restart automatically, and maps a physical folder on your server to hold the application's persistent data. If you are running Ollama alongside the dashboard, you have to be careful. Exposing the local model handler directly to the public internet creates a significant, dangerous entry point for completely unauthorized traffic. This network topology diagram illustrates the solution. By binding the Ollama port exclusively to the internal 127.0.0.1 address, external traffic hits a dead end. Only the Open WebUI container can safely communicate with the model handler over the internal network. With the security parameter set, execute the Compose Up command in detached mode. This ignites the entire stack, pulling the necessary images and launching the web interface quietly in the background. Restricting model access to the internal network means external actors cannot scan your IP address and use your server's computing power to process their own tasks. Before exposing anything to a web browser, lock down the machine. Configure the uncomplicated firewall to drop all incoming traffic, strictly allowing only SSH for administration, plus standard HTTP and HTTPS ports. To connect the internal containers to the outside world, install NGINX. It acts as a reverse proxy, standing at the front door of your server to catch requests and safely route them into the dashboard. Inside the NGINX configuration, direct traffic to the local port holding Open WebUI. Make sure to define the upgrade and connection headers exactly as shown here. This ensures the dashboard can maintain the continuous WebSocket connection needed for real-time chat responses. Next, run Certbot. This utility reaches out to Let's Encrypt, verifies your domain ownership, and instantly provisions a cryptographic SSL certificate to secure the connection. As part of the Certbot setup, configure the system to automatically redirect any plain HTTP request directly into the encrypted HTTPS tunnel. You will be entering prompts, managing passwords, and potentially uploading private documents. Routing traffic through this secure reverse proxy ensures no one can intercept your data in transit. Though the interface runs smoothly, your user accounts, chat histories, and settings live inside Docker volumes. If that volume is deleted, the data is gone. To back this up safely, spin up a temporary, lightweight Alpine container. By mounting both the active data volume and a local backup folder into this microcontainer, you can compress the entire system state into a single, portable archive file. Taking one backup is a start, but automation is better. Inject this specific extraction command into a server cron job, scheduling it to run automatically every night while you sleep. If hardware failure or a bad update wipes your system, the restoration path is incredibly straightforward. Stop the active stack, mount the volume again, and run the exact inverse command to unpack the archive and restore the state perfectly. The container logic can be rebuilt in seconds, but your ongoing chat logs and configuration settings cannot. A robust backup protocol is what actually makes the deployment permanent. With the safety nets in place, log into your server and execute the Docker command to pull a local model framework directly into the Ollama environment. Open the dashboard in your browser and complete the initial administrative login. Before doing anything else, navigate to the settings and disable public registration so random visitors cannot create accounts on your private hardware. As you begin pulling multiple models, pay close attention to server response times. If the terminal freezes or the interface slows down, your machine is likely exhausting its memory. You can diagnose this by running the free command to check RAM availability. If you continually hit this memory ceiling, do not attempt to force the workload. Power down the machine, log into your hosting provider's control panel, and scale up your VPS plan to a higher tier with more CPU cores and RAM. A local deployment requires active monitoring. As your use case grows to handle heavier, complex models, your hardware allocations must scale directly alongside it. Visit your secure domain, sign in, and send your first query to the local model. The interface feels like a commercial platform, but the mechanics underneath are entirely under your management. When you hit submit, your prompt is not beamed to a corporate data center. The logic, the processing, and the response stream remain perfectly confined within the physical boundaries of your server. You now operate a custom-routed dashboard wrapped in cryptographic security. The intelligence engine is strictly isolated from external networks, and the entire operational state is backed up automatically. Practical oversight in artificial intelligence starts with infrastructure. When you manage both the interface and the hardware, you ensure that your data and your compute resources remain entirely under your own supervision.